Hi everyone, welcome to this lecture. So in this lecture, we will learn about the fundamental concept of perceptron. That is, what is the definition of perceptron, what we can do with the perceptron. So perceptron is the fundamental unit of any neural network. With the help of perceptron, we can do a lot of things, like we can perform any kind of mathematics with the help of perceptron, like addition, subtraction, taking logarithm, exponent, or any kind of simple and any kind of complex mathematics. Similarly, we can do regression analysis with the help of perceptron. Similarly, we can perform classification with the help of perceptron. So there are many things which we can do with the perceptron. So what is the definition or what is the concept of the perceptron, or from where the concept of the perceptron arises? So we know that in our brain, there are millions of neurons present, and they are interconnected with each other with the help of electric signals or electric pulses. Look at this neuron. Now, this neuron is connected with this neuron, and this neuron with the help of electric signals or pulses. This neuron is getting inputs or the information from the previous neurons, and after processing the information, it is passing the signal to the next neuron. So in this way, every neuron has some input signal and some output signal. So here is another visualization of the brain neuron. Here we have written the input as a dendrites. These are the label for the inputs which are going into the neuron, and this brain neuron will do some processing with those input, and then it will generate the output for the next neurons. So the output of the brain neuron is axon, and the input to the brain neurons are called the dendrites. So this is another way of understanding the concept of a brain neuron. So inspiring from the working of a real neuron or the brain neuron, scientists developed the artificial neuron in the lab. So that artificial neuron is called perceptron. Here, this is our perceptron, and it is getting two kinds of input. Here we can see that X1 is the first input to this perceptron, and X2 is the second input to this perceptron. So what this perceptron will do? So this perceptron will do some processing on these inputs, then it will generate output for the next neurons. Okay, so this is our real neuron, and this is our artificial neuron. So this is present in our brain, so that's why it's a real neuron, and this is a neuron which is created in the lab by the scientists. Therefore, it is known as artificial neuron or the perceptron. So we can see that here the inspiration of the perceptron is from the working of a real neuron which is present in our brain. Now, here again, we can see the perceptron. Here the perceptron is getting two inputs, X1 and X2. Here we have associated the weights with both the input. So the weight associated with X1 is W1, and the weight associated with X2 is W2. So what is happening here? Here our perceptron, this is our perceptron. It is getting input and it is performing addition on the input. If we see the output equation of this perceptron, this is the addition equation, because the first input to this perceptron is W1 X1. This weight will be multiplied with this feature X1, and this weight will be multiplied with this second feature X2. And when they reach to the perceptron, they will be in the form of W1 X1 and W2 X2. So what perceptron is doing with both these input feature, it is performing the addition. So addition is one of the simplest form of mathematics. So we can add two input signals easily with the help of the perceptron. Now, student, this is the simplest form of a neural network. In a neural network, we have three kind of layers, basically: the input layer, the hidden layer, and the output layer. So the input layer is responsible to providing the input to the neural network. So mostly the perceptrons on which we are working or we do processing are present at the hidden layer. So this is our one perceptron. So this is called the simplest neural network because it has only one hidden layer and only one perceptron in the hidden layer. Now this perceptron will do processing on both these input signals or inputs, and then it is giving output to the output layer. So this is input layer, which is responsible to providing input to the perceptron. This is the perceptron which is present at the hidden layer of a neural network, and this perceptron is responsible to do some processing with the input signal, and after processing, this perceptron will give output to the output layer of the neural network. So neural network has three kind of layers: input, hidden layer, and the output layer. Here we can see that the output is again the sum of the two input signal, because here the perceptron is again performing the addition. So the important perceptrons are present at the hidden layer. That are the perceptron which do processing on the data. The neurons present at the input are only responsible for supplying data to the neurons or the perceptron which are present at the hidden layer. Most of the processing of the data is performed at the hidden layers, and after processing, the hidden layers providing output to the output neurons. So this is the simplest neuron due to two reasons. The first reason is that we have only one hidden layer, and the second reason is that we have only one perceptron in the hidden layer. Now, this is another form of a neural network. Now, we can see that here we have more than one neuron in the hidden layer. Again, we can see that the hidden layer is one. Here, there are no more than one hidden layer. This is our hidden layer, but this time we have two neurons in the hidden layer. Since they are hidden layers, we can call it H1 and H2. That is, they are the perceptron or the neurons of the hidden layers. Okay, now this neuron is getting signal from both of the input. That is, it is getting signal from X1 and X2. Similarly, this neuron is also getting input from both of the inputs, that is X1 and X2. The weights associated with those inputs are different. That is, X1 is going to H1 with the weight W11, and it is giving signal to H2 with the weight W21. Similarly, the weight of X2 with H1 is 12, and the weight of X2 with H2 is W22. So the weights are different. However, every input is connected with the neuron present at the hidden layer, and similarly every hidden layer neuron is connected to the neuron present at the output layer. Since every neuron is connected to the previous neuron and the neurons in the next layer, therefore the neural network is also known as fully connected network or a fully connected neural network. So this is the great example of a fully connected neural network where we have two perceptron in the hidden layer. Now we can observe one more thing. We just have added one more perceptron in the hidden layer. If we see the previous neural network, it had only one perceptron. Now we just have added one more perceptron, and we can see that a neural network has become more complex. So the complexity of a neural network increases exponentially if we increase the number of perceptron in the hidden layer. So hidden layer is still one. There is only one hidden layer still in this neural network. We just increase one more perceptron. This is the bias associated with this perceptron, and this is the bias associated with this perceptron. Similarly, this B3 is the bias associated with this output neuron. So the most important neurons, which are perceptron, are present at the hidden layer. They are responsible to process the data which they receive from the neurons present in the input layer, and after that they provide the output to the neurons present at the output layer. This is another example of a multi-layer neural network with two layers of a hidden neurons. Now we can see that here we have two hidden layers. This is our first hidden layer. This is our second hidden layer. This is our input layer, and this is our output layer. Here we have 5 neurons in our input layer. This is our first hidden layer with 1, 2, 3, 4, 5, 6 with 7 perceptron, and here we have 3 perceptron in our second hidden layer. Similarly, in our output layer, we also have 3 neuron. Now, if we see that every neuron is connected with the previous neuron and the neuron in the next layer, that's why the neural network is also known as a fully connected layer. So this is a multi-layer neural network. Now student, if we see that we have two hidden layers. So if in a neural network, we have two or more hidden layers, so that neural network is called a deep neural network. So the concept of a deep comes from the word depth. If the depth of neural network is two or more than two, it becomes a deep neural network. So this is our deep neural network because here we have two hidden layers in addition to input layer and the output layer. So we have two hidden layers present. That's why the depth of this neural network is 2, and it is considered as the simplest form of a deep neural network. It's not the simplest form of a neural network, but the simplest form of a deep neural network with depth equals to 2. Now, come back to the basic perceptron. In addition to perform simple addition, what we can do with the perceptron? So basically, with the help of perceptron, we can calculate the average of the input. If you see, this is 9, this is 3, and this is -6. If I add all of these values, I will get 6. So here, this addition sign will perform the addition, and after adding, we are dividing by 3 in order to calculate the average of the input signal. So therefore, the average here is 2. So we can see that after addition, we can also perform the averaging with the help of a simple perceptron. So we know that we can do any kind of mathematics with the perceptron. We can also do regression and classification with the perceptron, which we will study in detail in the coming lectures or in the coming sections of the course. This is another averaging machine. So we can see that here we have assigned the equal weight to all the input, that is 1/3. So what will happen? This 1/3 will be multiplied with 9. So we will get 1/3 into 9. This 1/3 will multiply with 3. We will get 1/3 by 3. This 1/3 will be multiplied with this -6. So we will get 1/3 -6. So if we solve all of this, we will again get a value equals to 2. So this is another way of performing averaging. Now here it is a weighted average machine. Weighted means that we have assigned the different weight to the input features according to their importance. Now this is 9, this is 3, and this is again -6. We have 3 inputs called x1, x2, and x3. We can also call them as a feature of our data. So every feature has different associated weight. So if we want to write the equation first and then put the value, we can do that. Like this branch has a weight W1, so it will multiply with X1. So this branch will give a signal called W1 X1 to this perceptron. Similarly, we get W2 X2 from this perceptron. And from third input branch, we get W3 X3, and it will reach to this central perceptron. Now, this perceptron is performing addition here. So the equation is W1 X1, which is coming from this branch, W2 X2, which is coming from this branch, and W3 X3, which is coming from this branch, and here is the addition. So this is the output of this neuron. So if we put these values here, we have X1 9 and W1 4. So this is our first product, this is our second, this is third, and here we get the addition from the perceptron, and we get 33. So we can see that we can do a lot of things with the help of a single perceptron. So in general, how many inputs we can provide to the single perceptron? So we can provide any number of inputs. Here we can see that we have inputs from x1 to xn. So the weight associated with x1 is w1. Similarly, with x2, we have the weight w2. And with xn, we have the weight wn. This is our bias, which is going into this perceptron, which is performing addition for us. So this is the total equation. Here we have n number of input features. So the equation is the sum of all the features. Here I is from 1 to n. And it is wi xi plus b. There is only one bias, but we have n number of input feature to this perceptron. So we can write the output equation of this perceptron like this. So if I put I equals to 1, I will get W1 X1. If I put I equals to 2, I will get W2 X2. If I put I is equals to 3, I will get W3 X3. Similarly, if I put the last value of I, which is N, I will get Wn and Xn. So basically, this Y is basically W1 X1 plus W2 X2 plus W3 X3 plus B. And this is the compact form of the equation. So this is the general representation of the basic perceptron. So we can see that we can give as many input to the perceptron as we can, but there is only one bias associated with each perceptron. So in this lecture, we learn about the fundamental concept of a perceptron. We see we can perform a simple addition with the help of perceptron, and we also learn from where the concept of perceptron arises. In the coming lectures, we will make more use of the perceptron. We will see how perceptron can be used in regression and classification. So I hope you understood this fundamental lecture on the perceptron. Thanks for listening, and I will see you in the next lecture.